Bienvenue à Nick Does Maths. Today we're going to be playing with some polar coordinates. So what do we got? We've got two curves expressed in polar coordinates. R1 is cos theta, theta is between 0 and pi. R2 is 1 over cos theta minus sine theta, with theta is between minus pi over 4 and 5 pi over 4. Our job is to find the area of the smaller of the two regions bounded by the two curves. Now, step one is mild panic, heart attack. When I read this, I was like, what? So hang on, I need to figure out what these curves are, figure out where they intersect, find the smaller of the two areas. It means there's two possible areas. But then I thought, well, the first thing we need to do is try and draw these things, right? Let's try and draw them. And once you try and draw them, it's actually not that bad. It's actually not that bad. So let's have a little look-see at R1. Now, R1 equals cos theta. We either know what it is, but we could also, right, we could also times R1 by, so let's have a look at R1. If we times everything by R, we end up with x squared plus y squared equals x, which is actually, with minimal fuss, a circle, radius a half, center a half, 0. So actually, it's not that big a deal. And if theta is going between 0 and pi, r will go from 1 to 0. And I think that does actually do what we want. Because it will go from minus 1 to 1, or 1 to minus 1 via 0, so we do get the whole circle. Now, if we look at R2 and multiply that one up, am I off screen there? Possibly. You end up with r cos theta minus r sine theta equals 1, which is just, well, x minus y equals 1. All right. Now, we are going from y is minus root 2 over 2 to minus root 2 over 2 to 0 to 1 back to root 2 over 2. So we'll see what this does. But now the point is these are probably much easier to draw. So what are we going to get? We got ourselves a circle. Radius a half, going up to 1. That should be 1. That should be minus 1. No, probably not, actually. Going up to a half, minus a half. And center a half. So that's nice. That's nice, isn't it? And then we've got y equals, if we rearrange this, which is that, give or take. So we would probably quite like to know where this intersects, because I, in fact, have drawn that poorly just because I know what the answer is. So let's figure out where they intersect so I can draw my picture properly. We want, let's do that here. Because actually, once we figure that one out, the rest of the question is quite easy. Is 1 over cos theta minus sine theta. So if we multiply this up, we get cos squared theta minus cos theta sine theta equals 1. Now, you could be forgiven for trying to go and do stuff in a whole bunch of double angle formulae, but I don't like that one. So what I'm going to do is, first of all, I'm going to scoot over here a little bit more so we get a bit more space. And replace the 1 with cos squared plus sine squared. And this is what I saw coming, because now that goes away. So we are left with sine squared theta plus cos theta sine theta equals 0, which is either sine theta equals 0 or sine theta plus cos theta equals 0. Now that will give me theta as 0 as an option. which we knew. I know it's gonna cross there, all right? Because when x is 1, y is 0. When x is 1, y is 0. So I knew it was going to cross there. So that's that point there. I've already got that one. Okay, fine. Now this one here, if we rearrange it, the barest minimum gives me tan theta is minus 1, which gives me theta is minus pi over 4. Okay, theta is minus pi over 4. So what's x equal to at that point? Right, what is x equal to at that point? Because that could be quite useful. Well, x is r cos theta. Well, x is just is cos squared theta. Wrong one, wrong question. Is cos squared theta, which is then a half at minus pi over 4. So in fact, we are going to cross there. So this is what I've got. And what I want is, if I exaggerate this a little bit, is what I would quite like is this. Well, I was already, right, I was geared up. I was like, originally when I originally, it's like, so hang on, I need to figure out, because these are just an absolute red herring. I need to figure out where these intersect. Then I'm going to have to integrate the two curves somehow and do some weird geometry and figure out the area between them. But what it turns out is, if we take our time to think carefully about what's going on, is we've got a quarter of a circle here, and I want to take away a triangle. Right. Well, okay then. Let's do that. So let's do the quarter circle. Quarter circle is 1/4 pi r squared. R is a half, so it's pi over 16. And then the triangle is half base times height. So my answer is going to be, pi over 16 minus 1/8. Done. That little bit there is pi over 16 minus 1/8. And this is what it means. That's why it meant the smaller of the two areas. You can have that one, and you could have all of that one there. So we wanted the minor sector. Segment even, the minor segment. So there we go. Sometimes it really is worth trying to really figure out what these things represent, because all of a sudden, instead of doing some horrible calculus, you're just doing some basic shape geometry, a quarter of a circle and a triangle. Doesn't get much easier than that in a further maths exam. Please don't forget to like the video, subscribe to the channel, and hit that bell notification somewhere down here somewhere, so that you know when more of these are coming out, and we can chat about maths together a little bit more. Hopefully you enjoyed it, you found it interesting. I certainly had fun doing it, and I will see you in the next video. Toodle pips.